Today we will present our final senior capstone project about safety enhancement of wheelchair, design, modification, and fabrication of attachments to get off a curb. First, I would like to introduce myself and my teammates. I'm Rayan Abdulghaffar, and my teammates are Abdullah and Abdulaziz Shaikh. In this presentation, we will go through the outline, background, retrofitted wheelchair, literature review, project description, design, conclusion, acknowledgement. To the background, as everyone knows, the wheelchair is a device that providing wheel mobility for people with difficulty in walk or moving from one place to another. 75 million people needs a wheelchair every day. The wheelchair is one of the most widely used assistive device for improving and promoting physical mobility. A quick history about the wheelchair, was invented by John Dawson in 1783 by building the first wheelchair with two large wheels in the back and one small wheel in the front. Through the years, the wheelchair developed by different people and improved the design to come up with two large wheels and two small wheels, which we still see in our days. In 1956, Everest and Jennings was the first company who developed the folding wheelchair, which we are using in our project. Moving to types of wheelchair. In our daily life, we see different types of wheelchairs and different designs. There are two main types, manual and electrical wheelchair. In our project, we are using a manual wheelchair since it's the best choice for several reasons. Manual wheelchairs are cost effective with little maintenance and requiring little storage space. The manual wheelchair, which we concentrate on, is usually fitted with two main side wheels and two front caster wheels. The four wheels on most wheelchairs have been designed in such a way that the wheelchair seat and the bottom of the wheels stay even and straight when the wheels are in contact with the level, even or flat ground surface that gives a smooth ride. Moving to motivation, why we are doing this project. Everyone knows close people using wheelchair who face difficulty in their daily life to move from one place to another. And we are taking this challenge to support individuals with mobility impairments to become more productive members of their communities. And those people can be children and adults or have physically challenged or different injuries. Need for the wheelchair. Number of needs for the wheelchair is increasing over the years. And nowadays, a study estimated about 17% of the people in the world have different disabilities. In the US, around 2.7 millions of people need a wheelchair. Moving to injuries related to wheelchair. This is our second motivation. So in 1990, there was a study estimated 100,000 cases of injuries related to wheelchair. And this number is increasing over years. So in 2003, this number increased to 100,000 cases. Now in 2020, cases reached to 300,000. And fall of a curb is one of the common injuries in wheelchair, which is one of our motivation.
The retrofitted wheelchair history. As a way of reducing the increase in energy, the wheelchair with the damping system was designed and developed by a group of students where they applied a front suspension with two follower wheels. And it's been carried out by Aaron Belt and Thompson, and prototype and design completed and built by Christopher. The objective of the project was to design a simple, efficient wheelchair capable of go off the curb without harming the person. And the retrofitted wheelchair is shown in the pictures. Retrofitted wheelchair and how it will be working. We studied the design in detail to find out how the system working. Starting in the figure one shows that the follower wheel appear no loading during the normal operation, and it is in the surface. And in the second figure show the follower wheel appear a lot, so it's release the slim latch through the action cable that will easily force the front caster wheel to go down after it's roll over the edge. The piston rod connected to the different movement of the damping unit, effecting of the ejecting the trailer. And here is the simulation show how the system is performs. Retrofitted wheelchair. And the result after we studying the retrofitted wheelchair and what they needed to improvement. So after we studying the retrofitted wheelchair design and tested in physical, we found out that when the rear wheel exit the curb, is transmitting a hard impact to the person, and that hard impact we need to improve to make it our improvement requirement. So, to our improvement requirement, we want to reduce the shock transmitting from the rear wheel to the user, and we want to make it want to make the system cost for cost and low and affordable. And the design and fabrication for our plan, we planning to use to installing a system into a rear wheel and the system that will be containing a rear suspension.
Moving to literature review. Our project seeks on rear suspension. There are different studies related, and people have done some work on the rear wheel, and we take that work and improve it and coming with a new way of redesign it. In these two designs, they used A-arm suspension, where it knows as a hinged suspension linked between upper and lower arms. Both examples are working to absorb the shock to an even surface. As you see in figure 1, the spring, in figure A, sorry, the spring attached between the frame and axle bar. And they used an elastomer as a shock absorber because it quickly recovers the energy that took to deform them. In figure B, as we show, the design attached shock absorber mounted between the frame and the axle of the rear wheel to reduce and absorb the shock transmitted from an even surface. Moving to our project description. The main goal of this project is to complete a functioning retrofitted wheelchair that meets a certain performance to travel over a curve.
So for our approach, as a team, we decides to implement a system on a both rear wheel to reduce the shock that transmitted from the rear wheel to individual. Also to boost the front wheelchair suspension, keeping the rider weight evener in the back of the chair. Along with that, we needed to determine how the suspension system influenced the dynamic stability of the wheelchair descent a curve. So we had to study different types of suspension in order to minimize the health risk to the user and to associate with gain of a curve. And our design consists of capability to lift 120 kilogram of load while keeping the chair parallel to the ground. Also, implementation of a rear suspension system will allow the disabled person to avoid back pain and much more comfortable and usually daily transported from one place to another. So we began with the first design by adding an A-arm suspension, where it contains a shock absorber, swing arm, and buffers. First, we removed both wheels an inch in standard position in the frame and redesign the frame. And then the upper side of the shock is linked to the frame, and the lower side is linked to the swing arm, where actually the swing arm is the connection between the center of the wheel and the bucket, as shown on the right. So in the next slide, showing the two position, and the system works such as when the wheel leaves the upper surface to the lower surface, the wheel from the rear damping mechanism will make a contact with the ground, and so to support the weight of the mechanism until both wheels rest to the lower surface. At the same time, the shock absorber will absorb the shock. So moving to design two, we came up with the second design was based on improving the stability and increasing the safety of the wheelchair. And the system consists of a horizontal bar, shock absorber, screw, and a channel, as shown on the right. And the horizontal bar attached under the seat to support the stability of the chair. And the upper side of the spring is linked to the horizontal bar, and the lower is the screw, where actually the screw is the main key for our body, goes from the center of the wheel through the channel to the shock. So the channel created 5 inches height on the back to allow the screw to go through it. And so the mechanism of the system, such as work when the rear wheel travels over a sidewalk onto the street, the screw reaction to will the inverse force will move up through the channel, where the shock absorber will prevent the screw to move up more than 2 to 3 inches. In the meanwhile, the shock absorber is going to absorb the shock that transmitted to the user. And in addition, we add bearing attached inside the channel to support the screw to move easily up and down safely. So in comparison between the two design, in design one, the shock absorber applied to the part cannot be built heavily load, which means loss efficiency, and the load did not act on the damper system significantly. Also, the rest of redesigning the frame is increasing the chance of deforming, so and much vibration, meaning it's low safety. And for design too, both shock absorber are attached to the horizontal bar to make sure it is stable. And the load wheelchair and the load on the wheelchair act is equivalent on the system. And so for design two, the vibration is more or less than the design one. Also, it's more comfortable and it's more safety. So obviously, the choice on design two was the most particular one. For our constraint for maximum efficiency, the design is limited to force about 1500 Newton, and increasing vibration may be experienced for travel over a curve 7 inches height. So we made a simulation, and generally simulation and modeling provide a clear feedback when designing a system to determine methods and analyze for better understanding. And in our project, we use different types of software such as SolidWorks and MATLAB. So for the MATLAB, we use the mass damper system as the concept of new low motion to find our spring constant and damper coefficient. For our system, the selecting system yield damping ratio of 1, meaning the vibration will come soon to steady after it hits the ground. And for our case, the natural frequency is 2.76 for low value, which means that the user will be comfortable. So we studied 3 different cases of condition: overdam, underdam, and critical dam. And for overdam, is oscillation is greater than 1, and for the underdam is experience which causes distortion. And so for the critical dam condition is to reduce the number of oscillation to absorbing the shock. So we used a Simulink to generate actually a diagram for a wheelchair spring and damper system, and the diagram helps selecting the best combination among the ones we consider between the K and the C. And so a quick around the diagram, we started with the input the force, And most the numbers are constant. We only applied different values for K and C to determine the best combination for our design. So as a result, in a Simulink, after we added different values of a spring, as you can see in the top right, different value of a spring constant and damper coefficient. And for our case, we choose a critical damper at a value of K500 and C as 100 because it provides less vibration to the user. What's the next? Yeah. So for simulation in a SolidWorks, we have done the three scenario using SolidWorks. The initial performance influence analysis of outcome when the wheelchair carries somebody. So first scenario when the wheelchair carries somebody in a sidewalk. And to complete this analysis, the model was subjected to 15 forces to determine the elementary stress allowance and in the figure indicated the specific extortion applying download of vertical forces as you can see. And so if we go to the second slide, yeah. And so for second scenario, as the wheelchair moves, the spring is compressed. The photo attached shows that the stress is distributed and it does not cause any strain or shaded in the blue. But you can see the small section above the spring that has different color shaded of a blue. That means the part experience higher strain, but the stress does not exceed 23.9, which means it's safe for the steel. And here shows how the action of the spring and the movement along the channel is basically showing our idea and how it's work whenever the rear wheel hits the ground. This is how gonna be the inverse of force. So for the third scenario, the force doubles when the wheel hits the ground to the reaction, and the force also now as act. It will like act as upwards. The blue region shows that the minimum stress experience, but the shaft has different color shaded indicated more stress, and that means the shaft is affected when the wheel hits the ground. So the specific So here is for the shaft. Here's the specific action showing in the video how the shaft is deformed. But if you can see the shadow is still blue and minimum for the stress, and that means that the stress does not exceed the 420 megapascal, which actually is the tensile strength for the steel itself. Also, it means that from the simulation, the design is safe for us and not deforming. So as a result, in a simulation, in different scenario, we applied 1500 Newton load extruded on the wheelchair, and we know the steel has a tensile strength of 420 megapascal, and the maximum stress we got in our simulation is 90.7 megapascal. And that means that the design is safe and it has lower value than the actual.
Fabrication the part. After we made our testing in the SolidWorks and modeling in the simulation, we started using to attachment those our idea the system into retrofitted wheelchair. Unfortunately, we couldn't complete in the experimentally physically because the COVID-19 we couldn't complete it and the school it was closed. There is some part here it has been done, but the rest of it we couldn't complete it.
Moving to conclusion and for our project. Through the project, we test the previous retrofitted wheelchair design to establish the need for improvement. The project involved improving the damping system by attaching shock absorber on both rear wheels. Due to the load acting on the springs, vibration reduces providing comfort for the user, and hence the equipment is safe for use.
for the future work, as we said in the beginning that we couldn't complete in the physical part, so our future work is completing the physical part and implement our system into the retrofitted wheelchair. Second, to test the design experimentally. And third, use a movement sensor, which is the obtaining determining the reaction before and after we adding our system. It's an opportunity to show the case's capabilities.
Acknowledgement. We would like to thank the Mechanical Engineering Department at the University of the District of Columbia for the use of facilities and support. We would like to thank Dean Shetty and Dr. Denis for their advising and sharing their experience on these subjects. And we would like also to thank Dr. Shaw for teaching us a design technique as well as supporting us throughout this process. And also we would like to thank at the end Mr. Pablo and Mr. Takili for their assistance. And here is our references. And here is the end of our project. Any questions?
All right. So we have time for a few questions. You can either type in through the chat box, or you can just unmute yourself and ask a question.
So I have a quick question. It's Dr. Tyagi from Mechanical Engineering Department. So did you use some like references, kind of like a standard for the material selected for your design of the wheelchair?
Yes, we did.
For
We did some research about our material and the stress of it and everything. So the mechanical properties of this of our material. And by that we determine the much stress we got, and by converted to our simulation, the maximum we got is not it's actually lower value from the actual material.
Okay, thank you.
All right.
Thank you. Any other questions? There is a question from the chat from Dr. Klein. Did the team calculate a factor of safety for their shock absorbing system?
Yes, we did.
Did the team calculating the factor safety of their shock absorber system? Yes, we did. Actually, to determine the force of it, we used 1.3, the factor safety of 2, which is indicating that if you use the factor safety of 2 until the 10, it will be a safety for our system.
Okay. Any other questions from the audience? I just want to remind everybody there is a link for submit your survey for this team. And I'm sending it again through the chat box. If you can check that and type in your feedback.
Professor, you sent us a evaluation sheet. Do you want us to fill that out as well in our emails?
Yeah, that's a different one. Yeah, this is for their presentation today. Yeah, so the link I just sent through the chat box. If you click that link, it should take you directly to a Google form. That's where you can fill out the survey for their presentation today. I saw another question from the chat box from Dr. Chen. What's a general idea to test experimentally?
So we tried to apply to do a test with the move sense to calculate the reaction of the person on the wheelchair to see before we applied the system and after. So that was our idea of the experimentally testing.
Okay. So you have the plan in your report, is that
Yes.
right? Okay.
You guys have a picture of the ramp that you built?
What is it?
The ramp for the 7 inches with a
The curve.
the impact force.
I didn't get the question.
No, did you have a picture of your setup for the ramp, for the wheelchair? Right, you had,
We don't have it in here.
okay.
It's in the report.
Okay.
So that is part of the plan. You want to assess your design before I think you did design that before the spring break. Is that right?
Yes.
Okay. Okay. And there's a comment from Dr. Chen again. There's a website called resna.org. It is a good place to showcase this type of device.
Sure.
So maybe you can check it out and adding, if there is useful information, I'm sure there is, to put in your report, so you can, you can further enhance the report. Okay.
Sure, we will go over the website. Thank you.
Mhm. All right. Any other questions? I have a couple minutes for a few more questions.
Dr. Denis mentioned, I think the ramp which they have built in the workshop can be included as appendix or somewhere, which gives a full picture of the testing.
That's right, teacher. Exactly.
Yes.
Right.
So, so as I guess as a team, we have worked on this project for almost a year. So, what is your, what is the most important thing you learned from your experience from working on this project?
Well, after we start in this project as a team, we learn how to communicate in between each other as a group, and how we can work as in the field. Also learn about all these 4 years what we have studied about the subject, how we can use it in the field, and how we can attachment our study in the field and help the other companies and stuff like that. For example, for the advanced manufacturing, we learn from the advanced manufacturing in our project. How if you want to change, if you want to develop any kind of project, you have to look the part, how you can assemble it, the price. That's the part, like how to develop it. For our part, we found a problem in the major retrofitted wheelchair, so we changed it. We made the shock absorber in the rear suspension.
Okay. So, how do you team communicate, and especially when you're preparing the presentation like this, and also your report, how do you each divide your work, and also put it together, a complete report and presentation from different parts of the team?
So based at the beginning, we were working at the school. We divided the work between the three of us. We divided the work. So who has more experience in the design, he worked for the design. Who has more experience in the calculation, he worked on that. So we divided the work between the three of us based on whoever has more experience on the thing that he like to work on.
Okay. I saw a question from the chat from Dr. Tiagi. So, where in the wheelchair metal 3D printed components can be utilized, for example, to increase the load bearing capability? And
So the retrofitted wheelchair, they actually mentioned that the highest capacity for the loading is 120 kilogram. So for ours, we cannot actually go up than 120 kilogram, since we applying our system in the retrofitted wheelchair. I hope I answered the question.
I think Dr. Tyagi wanted to know something else. Dr.
Okay.
Tyagi is asking where you can use a 3D printing, that is using the new machines we have, metal printing. So what sort of component of your wheelchair can be made using that machine?
We can, yeah, for ours, we can, the screw or the rod itself, because when we search about the rod itself, we couldn't find it, so we actually brought like, that I'm talking about the size. So we actually brought like a longer size, like around 12 inches, and
Show the picture. Show the picture. What screw you're talking about on the diagram or on your presentation.
Okay.
Yeah, go back to where you had the list of the parts. Yeah.
We actually didn't include it because we haven't done actually the screw. We just bought it, but we couldn't make the thread yet and cut it, and that's all.
But just show where would it be in your diagram, in your SolidWorks?
Yeah. So if a solid work, it's gonna be the shaft itself, the one is connecting between the frame, goes along the channel to the shock absorber. If you can see it. And here is looking at it. Here is it. Look at it. Here is the shaft. Yeah, I'm just showing you shaft or screw. Exactly. That one.
Okay.
Okay.
I think last question from Dr. Klein is, what was the most challenging aspect of your project?
So the most challenge was for our project,
Mhm.
if we can find a solution on how to reduce the shock, since many people have done many researches and many work, so we tried to go all over their field of their project or ideas, and trying to develop it of what we can do. Like we went over their field, what they have failed on.
What about the type of wheelchair? What about the wheelchair itself? Is it still in existence? Is it still in use?
Yes.
No, that type of wheelchair.
The type of our wheelchair, yeah, the company actually is closed. We couldn't find, we couldn't find any other wheelchairs. So we used the retrofitted wheelchair. Yes, this is one of our challenge. Also, the other challenge we faced is how to design it, because when we tried to implement the shock absorber in the wheelchair, it was hard to us to find a way to apply it, because the space from the under the seat to the center of the wheel is not that far. We don't have much space, so it was challenge for us to find a right design.
Yeah, so you mentioned a couple of constraints in
Yes.
design, and also, I think Dr. Dennis was asking, there is any existing, or similar design on the market, right? So, yeah.
No.
For the same wheelchair, no.
No, not for this wheelchair. That's the issue.
Yeah.
Yes.
For this wheelchair, no.
Yeah. Okay, so for time's sake, let's group for the presentation, and we'll move on to the second project. So please, if you can stop sharing the screen, or let the second group get their slides ready.